We're now moving on to topic 5.1 in the area of polynomials. Now, as you look at the word polynomial, poly is the prefix for many, and nomial, numbers. So we're going to be dealing with lots of vocabulary, and in fact, initially, there are 10 matching questions. Some of the terms: binomial, cubic, degree, descending order, leading term, linear, monomial, quadratic, quartic, and trinomial. Again, there's a good definition over here, and as we go along, we'll be picking up on that. The first thing is an interesting one, number 11, and it's to define whether or not this expression is, in fact, a polynomial. Now, there's a couple of qualifications, if you're reading your textbook, of what makes a true polynomial. Part A of that is that no variables in the denominator. And part B is no negative exponents. So you had to read that in the textbook, and it may be in our slideshow too. So as we look at example 11, there are two terms here. But here we see on the variable, there's a negative 2 exponent. Because of that, and that would be part B, this is not a polynomial. In example 12, they want us to identify the terms. Well, if you recall from chapter 1, we said terms in an expression are separated by either a negative sign or a positive sign. So as we look here, there are 3 terms. So this is the first term, this is the second term, and this is the third term. Now, when we list this term, we don't put the plus in. Any number without a sign in front of it, we assume is positive. So this is 3 terms. This would be what we call a trinomial. Now, within a term, for instance, in this term here, there is x squared, but it doesn't appear to be a number there. But there is, in fact, a number 1 there. We don't write it by convention. So often in a term, there may be a variable and a constant, or what we might call the numerical coefficient of that term. In this case, the numerical coefficient is 1. Here, the numerical coefficient is negative 4. Here, the numerical coefficient is 3. Now, another thing we're going to be looking at, so that was sort of like terms there, is degree. When we look at an expression and we're asked to say what is the degree of a term, it is the sum of the exponents on the variable. So here, the degree of this term would be a 2. That's the exponent by the x. Here, you look and you say, well, there's no exponent. But again, every letter has a 1 exponent. We just don't write it. So the degree of this term is 1. And here, there is no variable. Or if you put an x there and you put a 0 by there, you recall from chapter 1, anything to the 0 power is 1. So when there is no variable, we say the degree of that term is 0. Now, as we look at this, this is now an expression. It's made up of 3 terms. What is the degree of this expression? Well, the degree of this expression is the highest degree of any one term. So in this expression, the highest degree of any one term is 2. So the degree of this expression is 2. And a couple of other words that were mentioned is descending powers. In terms of x, when you have it like 2, 1, 0, the powers are going down. We say descending. This expression is set up in descending powers of x. If we reverse that and said ascending, starting with an A, we would have this one first, then this one, then this one. But usually we put it descending powers. Okay, some vocabulary. Okay, as we continue, they're asking for number 13 to define something when there are 3 terms. 1, 2, 3. This is a trinomial. And when there are 2 terms, this is a binomial. Now notice the prefix for 3 is tri. Prefix for 2 is bi. And the one that they aren't showing is monomial for 1 term. And then anything above that is the general classification of polynomial. But these are also polynomials, even though there's only 1 term or 2 or 3. In number 15, they're asking us to find the degree of each term in the polynomial. And here, it's going to be 5. So the degree of this one is 5. This one is 2. So the degree of that term is 2. Here it's 1. And we said when there's no letter, it's 0. Now, these are the degrees of the individual terms. What would be the degree of this expression? Well, as we said before, it's the highest one. So the degree of that expression is 5. All right, now let's look at this one. This one is 2. Now keep in mind there's a 1 there, so it's the sum of the exponents on the variables in an individual term. So this one is 3. There's a 2 and a 3, so this one is 5. This is 1. and this is 0. So the degree of this expression would be 5. Now, another vocabulary word that we mentioned briefly was coefficient, the numerical coefficient of each term. Well, there's a term. Again, terms are separated by either a positive or a negative sign. So, as we look at this term, the coefficient of this term would be a negative 8. This would be a positive 5. We wouldn't write the positive. Positive 6. Again, we wouldn't write the 6. And this one is, since it's a constant, it's 3. Okay, lots of stuff here, but just basic stuff that many of you probably know already. Okay, going into number 18, it's a multi-part question. First, they're asking how many terms are in this expression? Well, 1, 2, 3, 4. So there are 4 terms. What degree of each term? Well, this one's going to be 5, 1, 9, 7. What is the degree of the polynomial? Well, you look at it, the highest one is 9. So that's the degree of the polynomial. Now here is a new term. What is the leading term? Well, by definition, the leading term is that term that has the highest degree. So as we look at it, which term has the highest degree? Well, x to the 9th. What is the coefficient of the leading term? Well, the leading term was x to the 9th. What's the coefficient of that term? And the answer is a 1. Okay, now we'll do another one. I'll leave much of this up. Well, for 19, they're only asking what is the degree of this polynomial, but we can do all of these since I have them written down here. How many terms? Well, 1, 2, 3, 4. The degree of this term is 4. There's a 1 there and a 1 there, so this is 2. A 3 and a 2 is 5. A 1 and a 6 is 7. So the degree then of this polynomial, which is C here, would be the highest, which is 7. What would be the leading term? Again, it's the one with the highest number. This would be the leading term. What is the coefficient of the leading term? It's 15. So, again, they only asked us to do this one, which we said was 7. We just gave you a little more information on that. For this, number 20 and 21, they're asking us to write them in descending order. So we're looking for the highest degree, and here we see it's going to be 13a to the 5th plus 8a to the 4th minus 7a squared plus 2a plus 4. So there's 1, 2, 3, 4, 5 terms, and we have 5 terms. Notice we don't have a term a to the third power. In a later lesson, we're going to have to put in missing terms. And you might say, how would you put that in? Well, you would say plus 0 x to the third. Now, they're not asking for that here. But notice this has no value because it's 0. But it is a placeholder. But they're not asking that here. And what is the leading term? The leading term would be this. And the degree would be 5. Okay, in 21, what would be the highest degree? Well, y to the 8th. So negative 9 y to the 8th. Then we have negative 5 y to the third plus 6 y to the second plus 2y minus 8. And the degree of this leading term would be 8. The numerical coefficient would be a negative 9. Uh, 22 and 23, instead of descending, they wanted ascending. So you put the lowest degree first and then build it up. So I think you can do those. All right, for number 24, we're going into function notation again. And keep in mind we can always put a y here for our function notation. And we could use like a little t-chart. X and g of x here. So if x is 3, what will g be then? Well, we're going to go 15 minus 7 times 3. 7 times 3 is 21. A negative 21 plus 15 is a negative 6. And again, this use of a t-chart, when you have something like this to help organize your material, I think is a very good tool. Again, x and h of x, this is our y value. Here we're saying x is 3. So we're going to go 3 cubed minus, let's put an 8 there. So this is going to be 27. This is going to be a 9. 8 times 9 is 72 plus 3. And again, it's so critical that you put things in a parenthesis, watching the signs carefully. Here it's positive, so it's not too difficult. 3 to the third power is 27. 3 squared is 9. 9 times a negative 8 is a negative 72. So you can add these two together and get a 30. 30 minus that is a negative 42. Now I noticed on one of the tests that you were not doing these, you were doing them, but you weren't getting correct results. And part of it, you probably messed up on the signs in there somewhere. So set your work up, be careful, double check it. As you try your practice and then later your quiz bee, that will be your measure of how well you're doing. I don't want the tape to be too long, so I've done a lot of this. For number 26, again, we're dealing with function. They're saying this function of 2 and this function of 10. And this is the formula they're giving in which our value of x, which is 2, is substituted here. So again, a t-chart is very useful. We're going to look for a 2 and we're going to look for a 10. And then into this trinomial, we're going to substitute our 2, which is what I've done. Now, 2 squared is 4, so this is going to be 4 times 5 is 20. And this is going to be a negative 14 and a negative 2, which adds up to a negative 16 plus 20 gives me a 4. Now for the second one, we have where x is 10 in parentheses. As we square the 10, this gives us 100. Times 5 is 500. Minus 70 minus 2. So this is a negative 72 from 500, leaves me with 428. Now 27 gets a little complicated, but again, the use of parentheses is something you want to include to help keep it clear. So negative 3 doesn't change. There's our negative 5 that we're substituting for t, which is a negative 5. A negative 5 cubed is a negative 125. The opposite of a negative 125 is a positive 125. So we have negative 3 plus 125. That's critical to get the right sign there. Now, when we square a negative 5, we get a positive 25, which gives us 50. And then the opposite of a negative 5 is a positive 5. So this is like 180 minus 3, 177. This one's a little easy because we're going to put a t, replace it with a 0, which is what I've done. So this is negative 3. This is negative 0. Squaring a 0 is 0. 2 times 0 is 0. And this is 0. So we end up with a negative 3. Again, lots of stuff here. And as you do your practice and later the quiz me, that'll be your test to see how well you do on it. Now examples 34 to 39 are all combining like terms, adding. Now what I'm going to illustrate with 36 is just a method that might be very useful for you in adding like terms. And that is, change it from horizontal to something vertical. You'll see what I mean. So 2a plus 3b minus 4c. Now you look, since it's a positive between parentheses, you can just take away the parentheses, and then this is what you're going to add, a negative 5a. So what is your like term vertical column? Well, the a column is right here. So we're going to put a negative 5a under that a column. And then for b, we're going to put a negative, and you can put the 1 there if you like, b. And then here, this is a negative 7c. Now, for this one, you probably could do the original in your head. I'm showing you this to give you a method for possibly doing them when they get really difficult. Right now, this is easy, but the concept of setting them up in like-term vertical columns. So now, when you go to add, you're just going to get a negative 11c. The variables don't change when we add. We're just adding the numerical coefficients. And then here, this is going to become a plus 2b. And this is going to become a negative 3a. Now, could you have done that horizontally? Yes. This one was easy. What I'm illustrating is the technique. Okay, number 39 I thought I'd do. This is a more challenging one. And instead of writing it horizontally as they have in the booklet, I wrote it vertically in like-term columns. So we know our answer here is going to be AB. This is going to be A squared. And this is going to be A to the third. Now we have to add up this part. And in order to do so, in some cases I have to have common denominators of my fractions. So what I need to do here is to make the 5 into a 10 by multiplying it by 2. So this now becomes 2 tenths. And now I can add them up. And the same thing, I need to have this by 2. So this becomes 8 tenths. Then I can do it, and here there's no problem. So I have 2 tenths plus 7 tenths. I'm just going to add my numerators and get 9 tenths. Now here I have to do some subtraction. Subtract 3 from 8. That will give me a 5. 5 tenths. 5 tenths will simplify into 1/2. And again, you don't change the variables. And then here, in a sense, we're subtracting this from that, and we end up with a positive 5.3. And there's our answer for number 39. Again, I'm illustrating the technique of putting them in like-term columns. And here a little bit of review from chapter 1, where we worked with making equivalent fractions that we can add or subtract. Okay, as we move on to examples 42 to 48, these are all subtraction problems. Now notice, prior to this, there was a plus sign. That is, we're adding. But now, between the parentheses, there's a negative sign. And the key to this is, in algebra, when they ask us to subtract, here's what we do. This is critical. We change the negative sign to a positive, and then we go into the parentheses and change each of these signs. So this will become a positive, and this will become a negative. Now we're adding like we did before, and again, the concept of putting them in like-term columns. 3r, this is now a positive 5r. This is a negative 1, that's a negative 10. This is going to be 8r minus 11. So we subtracted by changing the negative sign that indicates subtraction to a positive. and then going internally as we remove the parentheses, changing each of those signs. We'll do one more. So once again, we know this is subtraction due to the negative sign between the parentheses. For this one, again, we just remove the parentheses. But when we have a negative sign in front of the parentheses, the rule is we make that plus, and then each sign of the terms inside the parenthesis we change. And again, my strong advice, line them up in like term columns. Now I happen to save myself from writing that again. They are like term columns. Here this will be a plus 9y squared. Notice these cancel out, so there's no term there. And then this becomes 11x squared. That's your final answer. Okay? Now, the last two, using a graphing calculator, we're not going to do. But again, the rule, when you see a negative sign in front of a parenthesis, just make that positive and then change each sign of each term to its opposite. Then you add. Putting them in like term columns, a very good technique. Good luck on this now.